A three-phase induction motor is a type of electric motor widely used in various industrial and commercial applications due to its robustness, reliability, and efficiency. It operates on the principle of electromagnetic induction to convert electrical energy into mechanical energy, which allows it to drive mechanical loads. Stator. The stator is the stationary part of the motor and is composed of a stack of laminations with evenly spaced slots. It contains three sets of windings, typically distributed around the inner periphery, which are electrically displaced by 120 degrees from each other. Rotor. The rotor is the rotating part of the motor. It can be of two types, squirrel cage rotor and wound rotor. The most common type is the squirrel cage rotor, which consists of conductive bars placed in slots and short-circuited at both ends by end rings. Bearings. The motor contains bearings that support the rotor shaft and allow it to rotate smoothly. Power supply. The motor is connected to a three-phase AC power supply. The three phases are represented as phase A, phase B, and phase C. Rotating magnetic field. When the three-phase power supply is connected to the stator windings, it creates a rotating magnetic field due to the phase displacement of 120 degrees between the windings. The rotating magnetic field moves at a synchronous speed, which is dependent on the frequency and the number of poles in the stator winding. Induction in rotor. As the rotating magnetic field cuts across the conductive bars of the rotor, squirrel cage, it induces voltage in them. According to Faraday's law of electromagnetic induction, the changing magnetic field induces a current in the rotor bars. This current creates its magnetic field, which interacts with the stator's rotating magnetic field. Torque generation. The interaction between the rotating magnetic field of the stator and the induced magnetic field of the rotor causes the rotor to follow the rotating field of the stator. This creates a torque that drives the rotor to rotate. Slip. In practical applications, the rotor never reaches the synchronous speed of the rotating magnetic field. The difference between the synchronous speed and the actual rotor speed is called slip. Slip allows the motor to produce torque and do useful work. Overall, three-phase induction motors are widely used due to their simplicity, reliability, and ability to handle various industrial loads efficiently.